I would be much happier if Alibaba released Zimage Edit to directly compete with Flux 2 Klein, but since they only released Zimage Base, I'm just going to do a quick review. Conclusion first. Zimage Base is mainly designed for LoRa training. I guess Ostrus AI is pretty busy right now releasing the AI toolkit, so if you enjoy training LoRas, you can check out his video. Zimage Base brings back randomness and offers much better variety. It's far more creative and expressive. In contrast, Zimage Turbo is known for producing high-quality photorealistic images, but it has a major limitation: low diversity. Because it's a distilled model optimized for speed and includes a speed-up LoRa, it often produces very similar compositions, poses, and faces, even when using different seeds. I'll also show you how to set it up and make it run fast, even on machines with just 8 GB of VRAM. Let's get into it. Now let's talk about downloading the models. The official BF16 version of the Zimage model isn't that large, around 12 GB. You can definitely run it on an 8 GB VRAM system, as long as your system memory is high enough. However, this will make generation a bit slower. If you encounter out-of-memory or OOM errors, you should try the Q8 GGUF model, which is only about 7 GB. After downloading the diffusion model, you'll need two more files: the text encoder, QN3 4 billion parameter model from the ComfyUI link, and the VAE, also from the ComfyUI link. That's basically all you need. Once you're back in ComfyUI, make sure it's updated to the latest version. Inside ComfyUI, go to Manager, click Update All, and make sure everything installs properly. If you're using the portable package, I recommend updating ComfyUI by clicking Update ComfyUI.bat. After it finishes, ComfyUI will automatically pull the latest version from GitHub and handle all required environment packages. After restarting, you can confirm the update by going to Templates and checking whether the Zimage text-to-image workflow is available. If you can't run the workflow or encounter loading errors, it's usually because you didn't update using these steps, so keep that in mind. Walking through the workflow is pretty straightforward. I replaced the diffusion model loader with the GGUF loader, selected the Zimage Q8 model. For the CRIP loader, make sure you're using QN3 4B. You can set the device to CPU or default. The VAE setup is standard. Next, you set the image size using the empty SD3 latent image node. Because this model usually runs with CFG values between 4 and 7, you may need to add a negative prompt. However, in my testing, CFG 2.5 was already sufficient, but you can experiment and see what works best for you. The K-sampler setup is standard. Connect the model, positive prompt, negative prompt, empty latent image. Officially, Alibaba recommends 30 to 50 steps for Zimage. However, higher step counts don't necessarily improve quality, and in some cases they actually introduce artifacts. I reduced the steps to 20 and the artifacts disappeared. You can experiment with this yourself. CFG, keep it between 4 and 7. Sampler, default. Res, multi-step, simple. I haven't tested many other samplers, but feel free to try them. For most of my samples, 1024 by 1024 is a good standard for fast generation. Higher resolutions like 2048 by 2048 also work. Just keep in mind that higher resolutions use more VRAM and may cause the model to spill into system RAM, slowing things down. Once everything is set, you can start generating.
First off, remember this golden rule. Better prompts equal better results. Always craft your prompts carefully. It makes a huge difference. Now, I'm going to assume most of you already know the basics of image prompting. But here's the catch. It's not just about what you ask for, it's about how you ask for it. For example, let's say you want to generate Dwayne "The Rock" Johnson walking on a red carpet. Bad prompt: The Rock Johnson walking on red carpet. What happens? The AI struggles. It might miss his facial likeness, get the body type wrong, or produce a very generic-looking result. Better prompt: when you clearly describe his appearance, outfit, lighting, camera angle, and the red carpet atmosphere, the result is much more accurate. You get the real celebrity vibe, the right setting, and cinematic details that actually make the image pop. And this works the same way for Asian pop stars or anime characters. If you just say Jackson Wang or Kirito, you'll often get generic faces or incorrect outfits. But a detailed, descriptive prompt gives you results that are far closer to what you imagine. So remember, don't just name the subject, describe the scene, the mood, the lighting, and the style. That's how you get AI to truly understand your vision. Next, I wanted to test something very specific, whether both models can actually understand English text placement on a poster. This is the exact prompt I used. It's a cinematic fantasy poster of Lunafreya Nox Fleuret from Final Fantasy XV, with detailed scene description, lighting, composition, and most importantly, explicit typography instructions. At the bottom of the prompt, I clearly told the model where to place the text by defining the structure: top center text, bottom large title text, subtext below, and a tagline. I'm not just saying add text, I'm telling the model where the text goes, how it's layered, and what the hierarchy is. And honestly, both models did pretty well here. They understood English text, respected placement, and the results actually look like real fantasy RPG posters. Now, will you get a perfect result on the first generation? Probably not. You'll still need to regenerate a few times to fine-tune spacing, spelling, or font style. But let's be real, this is a simple task for these models, and they handled it just fine. So if your concern is whether these models can handle English typography and poster-style images, the answer is yes. As long as your prompt is structured clearly, they understand it. And once again, it comes back to the same rule. Clear prompts get clear results.
It's also worth mentioning how differently these models recognize people. Flux Klein hardly recognizes Asian stars, struggles with some Western ones, but does fairly well with certain anime characters. Zimage Base recognizes Chinese and Western celebrities, but not Japanese or Korean artists. Anime generation, however, works quite well. Zimage Turbo is clearly specialized for photorealism. It slightly improves Chinese artist results, but when it comes to anime, the output often leans toward 3D realistic styles instead of traditional 2D anime. Personally, I believe this all comes down to training data preferences and the sources each model was trained on. Next, let's talk about diversity and compatibility. Zimage Turbo, especially the diverse version, tends to lose variation. Different seeds often look very similar. Zimage Base actually performs better here, producing more diverse and expressive outputs. Flux Klein sits somewhere in the middle, but in some cases it simply can't generate the images I want at all, which makes it less compatible for certain use cases. So to summarize, Turbo, speed plus photorealism. Clean results, very fast, but low diversity. Base, creativity and randomness. Slower, but ideal for LoRa training and expressive variations. Klein, a workflow powerhouse. Excellent for real-time editing, multi-image references, and balancing speed with quality, especially for editing-focused projects. So which model should you choose? It really depends on your goal. If you want quick, clean, photorealistic results, go Turbo. If you want creativity and expressive diversity, go Base. If you need workflow flexibility and editing tools, go Klein. That's my AI model guide for Zimage and Flux Klein. I made this video mainly to support my previous one, so I decided to release them together. Hopefully we'll see more interesting open source AI models in the future, so I can share more than just regular updates with you all. Have fun playing with AI, and I'll see you in the next video.